skin is first and foremost a barrier for us to the outside world, and it's going to do a lot of things that you would expect any barrier to be able to do. It is a protective covering, which makes it a very good barrier against harmful substances, in particular microorganisms. It does prevent water loss. It doesn't completely prevent water loss. In fact, part of its function is to help regulate water. It has sensory receptors in it. A great deal of our nervous system is housed in our skin to detect things in the outside world. It does get rid of some waste for us. One of the things it can do is help produce vitamin D from cholesterol. And it's very important in regulating body temperature. It's important to regulate body temperature because just a slight shift can really disrupt the rates of metabolic reactions. The set point for body temperature is monitored by the hypothalamus. Deep body temperature stays pretty close to 37 degrees Celsius, which you are probably more familiar with 98.6 degrees Fahrenheit, but you're going to have to get used to 37 degrees Celsius if you're going into nursing. The skin plays a key role in homeostatic mechanisms that are going to help regulate body temperature. Heat is produced by cellular metabolism. Most active body cells are major heat producers, including skeletal muscle, cardiac muscle, liver cells. When the body's too warm, the body responds by vasodilation. So the dermal blood vessels bring more blood up, and the heat in the blood can be radiated outward. Or vasoconstriction of deeper blood vessels so that the heat makes its way to the skin. It can do that through radiation, which is infrared heat rays escaping. Do it by conduction. If you hold something cool, the heat will move to cooler objects. It can be by convection, heat loss in circulating air currents, and evaporation. As water converts into a gas, it takes heat away with it. Water has a high heat of vaporization. So when body temperature rises, the thermoreceptors signal the hypothalamus. That leads to vasodilation in the dermal blood vessels, and our sweat glands become activated. On the other side of that coin, when body temperature falls, thermoreceptors will signal the hypothalamus. Vasoconstriction of the dermal blood vessels will occur. Sweat glands will become less active, and muscles can start to contract involuntarily. Those skeletal muscle contractions are generating heat, not movement, and we call that shivering. There are some problems that can occur in temperature regulation. Hyperthermia is an abnormally high body temperature. That can occur on hot, humid days when sweat can't evaporate. When air temperature is high, radiation of heat is less effective. The body may gain heat from the hotter air. Hyperthermia can lead to skin becoming dry, person getting weak, dizzy, nauseous, headache, and rapid pulse. The other side of that coin is hypothermia, which is an abnormally low body temperature. That can result from prolonged exposure to cold or to illness. Shivering is the involuntary skeletal muscle contraction instituted by the hypothalamus. That can lead to confusion, lethargy, loss of reflexes, and eventually consciousness. Without treatment, organs will begin to shut down. So an elevated body temperature, the loss of homeostatic temperature control mechanism in an extremely hot environment leads to the fact that heat can overwhelm temperature control mechanisms. That leads to hyperthermia. If the body heat builds faster than heat can be lost from the body, the temperature will rise even if the set point is normal. That can lead to extreme vasodilation, which can collapse parts of the cardiovascular system, hypovolemic shock, and that can be fatal. Fever, on the other hand, is an elevated temperature caused by the immune system to help fight infection. Phagocytes, things like macrophages, release chemicals called pyrogens, which increase the set point of the body temperature. And that elevated temperature helps to destroy pathogens. It helps to make our enzymes work a little better, and it also sequesters some important nutrients, making them unavailable to pathogens.